Welcome to Study Loop.
How does a cell become more negative on the inside versus the outside? The protein, the membrane protein that accomplishes this is the sodium potassium pump. And what I've drawn here is a very simplistic diagram of that. So on this side, we are inside the cell, and on this side, we are outside of the cell, and this is the membrane right here. Okay, and the pump sits in the membrane, and what the pump does is it pumps sodium and potassium, right? It's a sodium potassium pump. So before sodium potassium pump does anything, let's do a tally of our charges. So we have 3 positive charges on the outside. We have 3K plus 3 potassiums. So we have 3 plus charges. And we also have 3 sodiums on the inside. So we have 3 plus. How does a sodium potassium pump work? A sodium potassium pump uses ATP. It uses energy. All pumps use energy. So think of like a water pump, right? You have to plug it in to move the water. So that's kind of where the name comes from. A protein that is called a pump uses energy to move substrates across a membrane. It doesn't do this in an equal way for sodium and potassium. It puts out 3 sodium and it brings in 2 potassium. So in this very simple example that we have here, uh, if the potassium pump uses one ATP to do one of its cycle, the scenario that we end up with, so let me draw the pump here again. This is my membrane, and again, this is out of the cell, this is in. So initially, we had 3 sodiums on the inside, but the pump puts out 3 sodiums on the outside. So now on the inside, we will have no sodiums. That's the Na plus. And there will be 3 sodiums outside. And it brings in 2 potassiums. So it brings in 2 potassiums. But we still have one of the potassiums left outside because it only brought in 2. So now let's do a tally of our charges again out here. So on this side, we have 4 plus charges. On this side, we have 2 plus charges. And if you see now, the difference between the outside and the inside is a -2, right? 2 minus 4 is -2, whereas 3 minus 3 is 0. So that is how the sodium potassium pump establishes a net negative charge inside the cell. It uh, puts more sodiums, more positive charges out, and it brings positive charges in. So think about it this way: if you spend more money than you earn, your bank is going to be in the negative, right? If you put out more positives than you bring in, you are going to be in the net negative. So choice A is the correct choice here. The sodium potassium pump forces out 3 positive ions for every 2 ions it pumps in. Choice B is incorrect because the identity of the ions. Choice B says that it puts out 3 potassiums and brings in 2 sodiums. It's the other way around. It's important to kind of memorize that. And choice C and D. So choice C, it says that it makes the membrane more permeable. It does not affect the properties of the membrane. Choice D is it makes the membrane impermeable. Yeah, so both C and D deal with modulating properties of the membrane, and the sodium potassium pump doesn't affect the properties of the membrane. So choice A is the only correct choice here.